not bad, and I like it better. Um, There's some critical values for your z-scores, so let's just go over this for a second. So I'm here in the left tail test. I'm going to just do a left tail test for each one and a right tail test for one and a two tail test. So for this guy, let me take a left tail test. Oops, sorry. There's a left tail test. Alright, my level of significance is 0.10. I need to know the z-score that is associated with that area. So I take my calculator and I say second Baer's inverse norm. And I just say 0.10. So tell me what that is. So that's negative 1.28. See that z-score? For that area. The area of that curve is 0.10, 10% of my curve. What is that z-score associated with that? It's negative 1.28. Now, if I did it on the right-hand side, and this is still area 0.10, if I find this z critical value, I look up in my calculator, technically 90%, because I'm looking up area to the left. But if I looked up 10% and I got a negative 1.28, what would this guy be? A positive 1.28. So we remember that. You could also do it on your calculator if you like. You could do it with the 0.10, or if you want to, you're looking up the area to the left, you could do 1 minus 0.10. And this will give you the positive. But because you know there's symmetry, you're okay with the symmetry. Now, the two-tail test is a little different. The two-tail test says, kind of like we did with the inverse norm that we always used to do, the 1 minus 0.90, it says you're sharing 0.10 between these two tails. Because remember we took it and we multiplied it, your p-val, by 2? But now it's the opposite. You're sharing this. So if I divide this by 2, each one of these is 0.05. But they still have the same z number, right? So this is a negative z critical and a positive z critical. I have two ways to do this. I could go to my inverse norm, and I could just say 0.05 and paste. And I get my negative 1.645. Now my negative 1.645, if this is negative 1.645, this is positive 1.645. If you don't want to divide it yourself, just don't do the 1 minus, because this is already the 1 minus. Just come in here and say 0.10 divided by 2. Let the calculator do the division. And it will still give you your negative 1.645. Okay? So to find the critical value for your level of significance, this is where my cutoff is going to be. We're going to do an inverse norm, and you're going to just make sure if it's on the left side it's negative, if it's on the right side it's positive, if it's a two-tailed test, that you share that area. Okay? That's all we have to do for this. So let's try some. And it works the same with any of those. Alright, so we're going to find a critical value in a reject region area for a left tail test of 0.01. Alright, so we're going to do this. We're going to sketch. We're going to do this. And this is extremely important. You're going to label this reject H0. This is the little area that I'm not going to accept, right? This is my fail to reject H0. So a left tail test for 0.01. I need this critical value. I call it a ZC, critical value. It is actually a cutoff point. All Okay, should it be negative or positive? It should be negative. It's on my left-hand side, right? So how do I find this? I go to my calc. What do I do? Inverse norm. Good. What do I put in? .01. Isn't that what they asked me for .01? .01. That's all I want. It's just a little 1% that's sitting right there. I find my thing, and it's negative 2.33. And we knew it would be negative, so that's my critical value. When I test my z-score like I normally do, it's either going to fall to the left of this or to the right of this, and there's my decision. Okay? All right. I don't need to try that one. The left one's easy. It's the right one and the other one. So let's do a two-tailed test of .05. I have two tails. They're both reject H0. This is a fail to reject H0. Means I get two critical values. One has a negative, one has a positive. And they're going to share .05. So how do I find this critical value? Stephen, what should I do? Inverse norm. What do you want to put in? Well, .05 is my starting point, but I'm going to have to share it with how many pieces? 2. So I'm going to divide this by 2. Right? When I only have 1, I divide it by 1, it stays the same. But I have to share it, so I have to divide it by 2. So I get negative 1.96. And what's this side? 0.196. So I have two critical values. One is negative, one is positive. I have symmetry in my graph, so I don't have to worry about this. Okay? Okay. All right, let's put this together. All right, now. I don't want that. So your guidelines, again, same thing that we did before. We're going to verify that we know the population standard deviation because that's this little section. We're going to know that our population is normally distributed. Our n is greater than or equal to 30. They got to tell us that. We're going to state your claim. From your claim, we're going to figure out who's your HO, who's your HA. We're going to take your level of significance. We're going to sketch the tail. And then we're going to find your critical value. Table 4, you use inverse norm. Make yourself a little note on your note packet. We're going to do your test statistic. We're going to see where does it fall, and our decision is right there on your graph. And then we're going to interpret, just like we normally do. So let's give this a run. You'll see, I like this one better than the other one. Okay, so I'm on example 9. On page 371. Employees at a construction and mining company claim, oh, here's our claim right here, here's our claim, ... that the mean salary of the company's mechanical engineers is less than that of its competitor's salary, which is $68,000. So, what's my claim? My mean less than 68,000. Is this an HO or an HA? HA. What's my HO? Okay. They're employees. Now, look who's making this claim. The employees are making this claim. Do you think it would be the company's CEO making this claim? What would the company's CEO say instead? Making more. They would say, my company makes more than the other company. But the employees are like, hey, I know all these people that work at this other company. I make so much less than them. So the employees are making this claim. Okay? If I bounce down here, test the employee's claim. So this is my employee's claim. Now sometimes they say, do you support, do you reject? So with support reject says HA should use the word support, but they didn't say that, but that's okay. They still said test the employee's claim. So we're nowhere on track. Okay, so now, what tail test is this? Left tail test, follow the HA. So now I'm going to fill in, reject H0. Do this with me, guys. Fail to reject H0. I need to find this critical cutoff. That critical cutoff is based on my level of significance. That means this area should be 0.05. Okay, so I either can go to my chart, which is already done for me, or I can go to my inverse norm. So I do second Bayes inverse norm, and I say 0.05. Do I have to share this with anything else? No. So I come down here, and I paste. And it's negative 1.645. Okay, this is my critical cutoff value. Right? Now, I'm going to test this claim. I take out my test information, which follows. A random sample of 20. Here's my test information. My N is 20. Blah, 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 blah. Has a mean salary. My X bar is 66,900. Okay? And a population standard deviation of 5,500. That population standard deviation is fairly high. Okay? And they tell me my population is normally distributed because my N is less than 30. So they got to tell me that. So now, I do my z-score. And I say, X minus the mean. It's a sample, so I've got to do this piece to it. I take my X bar minus my population, which is my claim, and we divide by your standard deviation. You can still do this in the calc. I'll do it in the calc for you in a minute. Divided by 20. We put this in correctly, and we get a z-score of negative 0.89. This is called my test statistic. It's called my test statistic because it came from my test information. What I tested this with. Now, here's the beauty of this. We look at this number line. Zeros in the middle. Does negative 0.89 fall to the left of negative 1.645 or to the right of negative 1.645? To the right. Somewhere around here is my negative 0.89. What's my decision? Fail to reject. So my decision is right there staring at me. Fail to reject H0. There's my decision. I don't have to test any p-vals. But let's talk p-vals for a minute. My p-val, where would my p-val come from? Where would I find my p-val? From my z-score. So I look at my table, negative 0.89. I look at my table, and I find my p-val. I didn't, but I just want to make sure I show this to you. 0.89 is 1867. That's associated with that z-score. Normally you did this. P-val, level of significance. 1867 to 0.05, and we said this is greater. Didn't we fail to reject? So all we did this time was the flip side of this. We used our z-scores and our z-score for this. These go together, these go together. So it's the same information, just looking at it from a different viewpoint. Instead of looking at areas, I'm looking at z-scores. I don't have to do this test. I avoid this. Because now, I go right here and there's my decision staring at me. Make sense? But it is the same information I'm looking at. Either I'm looking at area or I'm looking at z-score. Okay? Let's try another one. Let's try the next one together. And then we'll do a two-tailed test. Is it a two-tailed test? Yeah, it is. Okay. So let's try this guy. A CEO of the firm, so here's my claims, and this is coming from my CEO, claims that the mean workday of the mechanical engineers is less than, here's my claim, mean is less than 8.5 hours. We just said a less than, didn't we? I'm not going to do this. Take this up. However, a random sample shows that it's 8.2 hours. Your CEO isn't going to want to make this claim be real strong because he doesn't want people to think that he overworks his people. But he's saying, I want them to work this many hours, and they're really not. So I'm not going to do that one because we just did a less than. I want to hit an equal to and a right tail test. I think both of these all right, let's do it. All right, let's do this one. Example 10. Let's do 10. A researcher claims, look, here's our claim, claims that the mean annual cost of raising a child aged 2 and under by a husband and wife families is, so here's my claim, the mean is $13,960 to raise that child with 2 people in the family aged 2 and under. The annual cost, annual. So if you're thinking about having a child right now, think again. So, all right. This is my claim. Trust me, your children are very expensive. That number goes up as your age goes up. Is this my HO or my HA? What's my HA? Okay. What tail test do I have? 2 tails. So I've got 2 areas that say reject H0. 2 areas that are really too small for me to consider. These are very extreme areas, aren't they? At the extreme ends of my curve. It's very small areas. But I label them reject HO. In the middle, fail to reject HO. I need to find this critical cutoff point. Because we're not going to use our areas, we're going to use our z-scores. So my level of significance is 0.10. So I come to my calculator, to my inverse norm, and I want you to do it logically. Come to inverse norm. You're at 0.10. Is anybody sharing your 0.10? Yes. So I'm going to divide this by 2. That's all you have to say to yourself. And I'm going to paste. So this guy is going to give me negative 1.645. So this guy's going to give me positive 1.645. These are called my critical values. So that's why I write ZC, a Z-score for a critical value. Okay, so now I should have some test information so I can test this. Here's my test. Blah, 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 blah. The sample, hang on. In a random sample of husband-wife families, the mean annual cost, X bar, is $13,725. The sample size is 500. Assume the population standard deviation is 23.45. Now notice, it didn't say normally distributed because my sample size is well above my 30, right? So they don't have to tell me normally distributed. They want to know, is there enough information to reject the claim? This is good. Let me go see if my claim is really HO. Because doesn't the HO use the reject words? So I look at my claim. Is my claim HO? So I'm good so far. So now I'm going to find my test statistic. So I'm going to take my X bar minus my mean, my population mean, over my standard deviation divided by my square root of n. So I'm going to plug this in, and this one makes it kind of nice, because I don't have to worry about finding the Z-score, multiplying my areas by 2. I get negative 2.24. This is my test statistic. Angelise. So tell me, Angelise, based on this, what's your decision? It's reject HO because where does that number fall? To the left of this guy, pretty far. What area does this fall in? In my reject HO. So watch how nice this is. So my decision is reject HO. Now my interpretation, what I make of this, is this. If I reject this, I kind of go along with this one, that it's not equal to this, right? But I can't really say that. So I follow my chart. My claim is my HO, and I rejected my HO. So I have to say this way. There is enough evidence, so this is what I want you to write, at a level of significance of 0.10 to reject the claim that, actually the researchers claim, that the mean cost of raising a child is $13,960. That's what I expect you to write. Okay. Soup to nuts. Now, if we were doing this with your p-val, if we were testing this with p-val, we would have to look this guy up in your table. We would look up negative 2.24. We get 0.0145, something like that. Yeah, 0.0125. And we would have to multiply this guy by 2. Because we had 2 pieces. But that's okay, because that we divided when we did this. So if you did this, you would be comparing this to your 0.10, which still shows the same answer, doesn't it? One we're looking at areas, one we're looking at Z-scores. We didn't change the format of this. We just changed the window we look at it. I happen to like this because I think it's visible. Like the p-value, you really have to think in your head that that value cannot be smaller than your most allowable value. And the book says extreme or more extreme. More extreme means you're further down your curve, which means your area is smaller and smaller. Isn't that very unusual when we're to the end of that curve? We normally don't have things like that.
Can you show how you got to the thing in the calculator again?
Oh, so the test, you had a test. So now you do this. You do stat, test. Whoops, I turn it on. I do stat, test. It's right there, z-test. I put in my population mean. That comes from your statement. That means your initial value here, 960. I put in my population standard deviation, which they had to give us, which is 2345. My test information, my mean was 1375. No, 13 what? 13,725. My N was 500. Now, this arrow follows your HA. Make sure you follow your HA. I look at my HA, and it's not equal. I use the not equal. If my HA was greater than, I use the greater than sign. So I calculate, and watch. It gives me my test statistic, this guy. It gives me my p-val, this one, that we found ourselves. But it doesn't give me my critical value. That's the only difference. You have to find the critical value, and you have to test it. But it pretty much gives you everything you need to know. So I bypass all this business in here. I still do have to lay out those things. Good? So you guys now, try it yourself 10. Try it yourself 10 says, take this one, and now see if I can reject the claim at 0.01. Is this going to change this guy to 0.01? This information, your z-score information, will stay exactly the same. What will change? What will change at 0.01? The critical values. The critical values will change. This information is not going to change, because what is affected by my 0.01? Just my cutoff value. So find me your new cutoff value. That's all you have to do. Find me your cutoff value and see where does this fall for your new one, for your new cutoff value. Do this in green somewhere. Uh-huh. So remember, just get the new cutoff value. Good. Negative 2.575 and positive 2.575. Did everybody get that value? Because we had to take that and we had to share it with two things, right? We're going to divide it by 2. Now, if you test this clean, negative 2.24, where does it fall? To the right of this guy. So now, I'm in my fail to reject H0. So if I change that to 0.01, I'm going to fail to reject H0. Because now it's not as extreme as that number that you're going to tell me to check it. And then I would fail to reject it, so therefore, I would say there is not enough evidence to reject my claim, the researcher's claim, that the cost of the families is equal to 13,960. This is critical that you come back to this. Any questions? It's not a lot different. We're just changing the look of it a little bit. We changed the look. So I'm going to give you guys a book assignment that you can work on tomorrow in class. And these deal with reject regions. Reject regions only. That's a 23. These are for reject regions. On the test, I will tell you, solve this one using p-val, solve this one using reject region.
Okay. This more, the last problem I didn't get that, can you explain like how you did it exactly?
Yeah, all we changed, sure, point on our
Like contributions or?
yeah, we changed it, and we want to cut. This one is shared by two tabs, so we had to divide by two.
I didn't know what that was.
Yeah. If it's not shared, don't divide. If it's shared, divide.
Wait, how do you calculate again?
Two tabs.
Okay, it says in the problem
If
itself.
it'll say equal, if it equals a not equal, gives you two tabs.
Okay.
A table be not equal, so there's your two tabs.
Okay.
The reason why a not equal is two tails is this, guys. If I say something is equal to 3, something is not equal to 3, on my number line, here's 3. If it's not equal to 3, look where my tails go. I got 2 of them, don't I? They go in 2 different directions. A greater than is just 1 tail. A less than is 1 tail. But a 2 tails, not equal to, actually gives you 2 tails. So it stems off of this.